ডক্টর অঞ্জিতা মাঝি, এইচওডি অফ AI।
সুরজিৎ স্যার আছো দিকে? হ্যাঁ বলছি, তুমি তো সেশনটা নিয়েছো, তা স্টুডেন্টরা করবে, তারা কি হাতে কলমে কিছু করবে না শুধু শুনবে?
না না, শুধু শুনবে
স্যার, এটা শুধু শুনবে টক। এবার আপনি যদি কিছু ওই মানে সিমুলেশন রান করিয়ে ওই পিপিটির মতো দেখান, ওরা এমনি
না পুরোটাই তাই সিমুলেশন করেই দেখাবো হাতে কলমে।
এক্সাম্পল করিয়ে দেখাবেন, অসুবিধা কিছু নেই।
আমি ওই মানে দেখো আমার সার্কিট তো বানানো নেই, সব ওই করে করে দেখবো, করে করে যাবো, সেটা দেখবে।
হ্যাঁ হ্যাঁ হ্যাঁ, সেটা বেটার স্যার।
হ্যাঁ, সব সার্কিট দুম করে নিয়ে এসে সিমুলেশন রান করে দিলাম, তাতে মনে হয় স্টেপ গুলো খুব একটা ফলো হবে না। আমি সেভাবে সেজন্যই পিপিটি
আপনি করে দেখাবেন। আমি সেইভাবে করে দেখাইনি খুব একটা, আমি সার্কিট গুলো ডিজাইন করা ছিল সেইগুলো দেখিয়েছি, কয়েকটা স্যাম্পল।
আচ্ছা আচ্ছা আচ্ছা,
হ্যাঁ, তো আপনি একটু করে দেখিয়ে দেবেন, অসুবিধা নেই। ওরা আরো
শেয়ারিংটা কি একবার দেখে নেব।
আমি ওইটাই ভেবেছি যে করে করে দেখাবো,
হ্যাঁ হ্যাঁ,
4-5টা সার্কিট করে করে দেখাবো যে কিভাবে করতে হয়।
স্যার বেটার স্যার,
কারণ কোনো পিপিটি কিছু রেডি করিনি, এটা তো মানে হ্যান্ডস অন টাইপের জিনিস, যদিও নিজেরা করবে না, হ্যান্ডস অন টাইপের তো।
হ্যাঁ হ্যাঁ ঠিক আছে।
কি বলছি স্যার, একবার দেখে নিচ্ছি যে আপনি শেয়ার করতে পারছেন তো স্ক্রিনটা।
হ্যাঁ করুন,
এটা লিংকটা পাঠিয়ে দিচ্ছি।
ওইটা নিয়ে নেবে আজকে না?
হ্যাঁ হ্যাঁ হ্যাঁ, তো লগ আউট না করলে তুমি নিয়ে নেবে, তুমি মোবাইল থেকে যদি রিসিভ করে নাও তখন ঠিক আছে। লিখে দাও ইউটিউব লিংক মর্নিং সেশন।
এটা তোমরা কতদিনে সাবস্ক্রিপশন করেছো?
1 মাসে।
আচ্ছা, কত পড়ছে এটা 1 মাস?
1500 টাকা, 1550 মতো।
ইউজার
100।
গুগলেও তো
ইউজার
হয়ে যেত
100 স্যার।
ইউজার 100।
হ্যাঁ
সুজিত, গুগলেও তো হয়ে যেত যে এতে।
হ্যাঁ হয়ে যেত স্যার, কিন্তু কি এতে সুবিধাটা কি ওইটা বলে দাও, ওই ইউটিউবের সঙ্গে এটা ডাইরেক্ট মানে হচ্ছে লাইভ স্ট্রিমিং করা যাচ্ছে। হ্যাঁ, সেখানে এবার 200-300 স্টুডেন্টও দেখলে কোনো অসুবিধা নেই।
তবে অনুপম জিমিটের এটা করে গুগলেই করে ও ইউটিউবে স্ট্রিমিং করেছিল এর থ্রু দিয়ে, যে কি একটা,
সেটা তো একটা আপনার স্ট্রিমিং সফটওয়্যার দিয়ে।
হ্যাঁ, স্ট্রিমিং
সফটওয়্যারের প্রবলেম হচ্ছে যে কোনো সময় হ্যাং করে যেত।
আর আমাদের কলেজে নেট স্যার,
আর কলেজে নেটে তো হবেই না, কোনো ভরসা নেই।
পয়সা না,
মোবাইল দিয়ে হোস্ট করছি আর ডাইরেক্ট জুম থেকে ইউটিউবে স্ট্রিমিং হয়ে যাচ্ছে, সেটা একটা অ্যাডভান্টেজ আমাদের। স্যার আমরা 10 মিনিট পর স্টার্ট করছি।
হ্যাঁ করো না, আমি তেমনি ঢুকে দেখছি এটা, এই প্ল্যাটফর্মে শুনেছি কোনদিন প্রেজেন্ট করি। হ্যাঁ ঢুকলাম দেন আগে।
উদয় স্যার
বলো বলো।
বলছি স্যার একদম তাহলে 12:30টাতে স্টার্ট করছি, আর আপনার মোটামুটি কতক্ষণ টানবে তাও? 1 ঘন্টা?
1 ঘন্টা হয়ে যাবে, কারণ সার্কিট গুলো তো প্রেজেন্ট করবো, আমি বুঝতে পারছি না এবার কতক্ষণ ধরে ওরা টানতে পারবে। আচ্ছা, প্রেজেন্ট শেয়ার স্ক্রিন করলেই হয়ে যাবে তো? আর কি দেখবো শেয়ার স্ক্রিন করে?
হ্যাঁ হ্যাঁ হ্যাঁ,
একবার দেখে নিন,
একবার আপনি ওইটাই দেখে নিন। লোগোটা যাই তো ব্যাকগ্রাউন্ড।
তোমার পিপিটিটা খোলো না একদম, আমি তো এখানে দেখছি। হ্যাঁ স্যার আসছে।
এবার সুইচ করতে যখন হবে,
স্যার ক্লিয়ারলি আসছে একদম,
মানে যখন স্ক্রিন সুইচ করতে হবে, নিউ শেয়ার।
এবার ধরুন আপনি অন্য একটা উইন্ডোতে যেতে চাইবেন, তাহলে উপরে দেখুন শেয়ার নিউ আছে। ওইখানে গেলে আপনি অন্য একটা উইন্ডোতে চলে যেতে পারবেন, ধরুন মাল্টিসিম উইন্ডোটা।
হ্যাঁ এই যে
হ্যাঁ এটা আমি দেখাইনি, এটা আপনি দেখাবেন, এটা বেটার। হ্যাঁ আমি অনলাইন মোডটা দেখাইনি।
আচ্ছা আচ্ছা আচ্ছা,
হ্যাঁ
আমি এটা দিয়েই করেছি।
ইনস্টল করে যেটা করা হবে সেটা দেখিয়েছি, এটা অনলাইনটা আপনি দেখিয়ে দেন, সেটা বেটার। ঠিক আছে
সাথে মাল্টি
আচ্ছা
এটা এটাই ভালো হবে।
ঠিক 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 আছে।
ঠিক আছে
Shall we start, sir? Hello. Hello. Hello.
Hello. Hello, sir.
Yes, yes.
Am I audible?
Yes, I can hear you.
Okay, sir. Okay. So I'm just starting, sir, and then I will hand over.
Okay,
So,
sir.
warm greetings to all. Good afternoon to all the faculty members, staff, and the students, and to Dr. Uday Maji sir, who is the presenter for the day 4 session for the 1 week student workshop on virtual labs and tools. Now, sir is an HOD of the Department of AEI from HIT Haldia, and he's mainly the talk will be on the virtual lab using the multi-sim platform and how that is being applied for the case of electronic circuit analysis, dealing with the various components like the diodes, transistors, and the resistances and all that are very useful for any student of the electronics or electrical or instrumentation background. So with this valuable talk, I hope that all the participants will be very much motivated to know about the application of the multi-sim software in the extensive analysis of the lab and the usage of it in the implementation of the various experimental using the virtual platform. So with this short note, I just welcome sir, Dr. Uday Maji sir, to just contribute to the session 4, and I am handing over to you, sir. A warm greetings to you.
Thank you very much, sir. Thank you for inviting me to share this session with all the participants. Today, this particular topic, I'll be discussing about how to use multi-sim online software or online simulation software in case of various circuit design, especially digital electronic circuit. How to use this particular software or online software for the simulation of digital circuit by using various digital components. So as we are just at the end of the semester, those who have studied digital electronics, they have gone through all the different types of digital nodes and respective circuits. So I'll just briefly show you the circuits and also discuss how to simulate that on this particular platform. First of all, those who are very much new in this platform, just tell you, you just open the multisim.com, and if you have if you don't have any account in this particular site, first of all you have to create a create your own account. Then only you can create or simulate circuit in this platform. As under this pandemic situation, we are forced to enter into this virtual session. That's why it is a very beautiful platform to simulate whatever we are studying in theoretical platform by using simulator. So I must start with the very basic one. In our digital laboratories, we have different experiment. Starts with the implementation of various gates by using universal gate. So first of all, I will show you how to implement various gate by using universal gate. We all know mainly NAND and NOR are known as the universal gates, because by using these two gates we can implement any other gate. For example, this particular window, I hope everybody can observe that by using NAND gates here, first one is the NOR gate, second one is the AND gate, and that's how all the gates can be implemented. Similarly, by using the NOR gate also, we can implement NOT, OR, AND, XOR, etc. So let's start to implement few basic gates by using the universal NAND gate. So here you will have different kinds of component for circuit theory, analog electronics, and other circuit simulation. You will have different components at this particular terminal. So here from you can drag your required component into this main window, and in this particular section we have to draw the circuit. So this is the this last one is dedicated for the digital components. If you click here all the different types of discrete component will be available. So AND, OR, NOT, NAND, NOR, XOR are available. So for this particular circuit design, I required NAND gate. So if I click on NAND, 2 input, 3 input, 4 input, and multi-input NAND gate will be available. For the first time, let's go with the 2 input NAND gate only. So if I click here, just the particular gate will be available to us, and if we click on the window, that will be placed onto the screen. Then after first gate, if we want to implement NOT gate only, so you know the NOT gate circuit, if we just sort the 2 input terminal and make it 1, then it will act like a NOT gate. So for giving the input, we must select this particular digital constant terminal, input terminal. For giving any kind of input, especially the digital input, we must select this particular one as input. Now to connect, let us put some output, because we want to observe the simulation output at the output terminal. For that, let us place one LED. So LED will be available at this output terminal. If we click here, similar to other, it will be placed. We can place the LED at this terminal. Okay. So now do the connect. If we do the connection, just sort the 2 input terminal. Then from, if we just move our cursor to the terminal point, then one arrow sign will come, and by clicking here we can drag that line, and where to end we can click again. So by this way we can connect the terminals. Similarly, from the output terminal, if I bring that pointer here, it will be available. Then similarly drag it and finish our drawing at the input terminal of the LED, right? As the other terminal of the LED is open, so we must connect a ground terminal to complete the circuit here. So I am placing a ground terminal. Then similar to other, let's complete the connection and complete the circuit. So here I have completed the first and very basic circuit to implement a NOT gate by using the NAND gate. After that, after completion, we can simulate the circuit by click on this run button. So if I click on this button, now my circuit is simulation is started. So if I, as you know that NOT gate behavior, input 0, output 1, and input 1, output 0. Okay, so this is the first circuit implementation of NOT gate by using NAND gate. So to stop it, we can pause the simulation as well as we can stop the simulation. Once you stop the simulation, then only you can implement the next one. Okay, so let us do the next one. For next one, just one more easy circuit, that is implementation of AND gate by using NAND. So as we know that AND NAND gate is itself AND plus NOT. So if we complement the output of NAND gate, it will act as a AND gate. So for that we require two NAND gate here, and this time we need two input. So one input is already there. I can bring it from the basket, or I can copy it directly from here. Okay, so similar to previous, let's connect or join all the terminals, input terminals. We are joining here, and output of this gate connect to the next stage. So here my circuit is completed. So again I can simulate the circuit. So for 1 1 output is 1, and if I make any of them is 0, output will be 0, as the AND gate feature. For any of the input is 0, output is 0, but only for the 1 1 input, output is high. So this is the implementation of AND gate by using NAND. Then for the implementation of OR gate by using NAND, similar kind of circuit. We just need to complement the two input. We can name it here as well. Say, let us put it as X and this one as Y. So at the output of first two NAND gate, we will be getting X bar, Y bar, and then after, if I put that in second terminal, it will be X bar, Y bar, whole bar. And if we apply the De Morgan's rule, so you know it will come as X plus Y only. So here is the here we have completed the circuit to implement OR gate by using NAND gate. Let's simulate it. In case of OR gate, only for the 0 0 input, output is 0, and for any of the input equals to 1, output will be high. So that's what we are observing. 1 1 output is high, and 0 1 output is high, and 1 0 also output is high. So that's the implementation of OR gate by using NAND gate. Now the last one, that is implementation of XOR gate by using XOR gate by using NAND gate. Let's do it. Those who are observing at the other end, they can also open this particular software in online mode and do the experiment. So here I have completed the circuit for XOR gate by using NAND gate. So if I now simulate the circuit, we know that for XOR, similar input output is 0 and dissimilar input output is 1. So 0 0 is 0 and 1 0 dissimilar input 1 1 1 similar input output is 0 and 0 1 dissimilar input output is 1. So here is the implementation of XOR gate by using NAND. If I place one more NOT gate by using NAND itself, it will act like a XNOR gate, and by this way we can cover all the gates, all the basic gates by using NAND gates only. And similar to this one, if we use the NOT gate also, we can implement other basic gates. I'm not going through that topic because it is quite similar. So let us do the next experiment we have in our laboratory. That is the realization of adder and subtractor circuit. Okay. We know there are two types of adder we have. One is called half adder, another is called full adder. Half adder consists of 2 inputs and 2 outputs, whereas full adder consists of 3 inputs but 2 outputs. So this is the very popular circuit. If we apply the Boolean's algebra based on this particular truth table, then we will be getting the sum equation as A XOR B and carry equation as AB only. So based on that equation, circuit diagram is this one, and for full adder we have 3 inputs, augend, addend and the previous carry, and similarly we can have 2 output, carry and sum, and based on the input section we will be getting various outputs. And if we apply the maybe Carnot map or through the Boolean algebra only, we can summarize that carry expression is given by Z x XOR y plus xy, and sum equation is in the form of x XOR y XOR z, and for that circuit diagram is like this, consisting of 2 input XOR gate. Someone can use 3 input XOR gate also, no problem in it, and 2 AND gate part, and finally the OR term. So if we simulate the same by using the same software, one more interesting part of this particular simulator, once you log in, you can also save your circuit in this platform for future uses. So here, just before, I have drawn this circuit. I am presenting in front of you. The drawing procedure is exactly same. So here is my half adder circuit. For that, I need one 2 input XOR gate taken from this basket, and one 2 input AND gate, and 2 inputs given in the form of X and Y, and outputs are named as sum and carry. Similarly, if I simulate this particular circuit, we know for 0 0 addition, 0 plus 0 output is 0 0, and 1 plus 0, or 0 plus 1 is sum is 1, carry is 0, and only for the 1 plus 1, 1 plus 1, carry equals to 1 and sum equals to 0. It is come in the form of as 1 plus 1 is 2 and binary 2 is presented as 1 0. So carry is 1, sum is 0, altogether it is presenting 2. Similarly, the full order circuit has been drawn before. I am presenting in front of you. So here is the full adder circuit. The three inputs X, Y, and last one let's name it as Z. That is the previous carry, and two consecutive section, XOR, two XOR gate, two AND gate, and OR gate. And very beautiful feature of this circuit, you can observe two half adder as well, as you have just observed that half adder circuit. So this particular section is one half adder and this section is another half adder. So by using two half adder, this circuit is implemented. And if you solve the truth table by using Carnot map, you will be getting different expression for carry xy plus yz plus zx, and that equation you can also implement, but function of that circuit will also be same. So here once again, if I simulate this circuit, so for all 0, output must be 0, and depending on the input, for 1, sum is in only single 1, sum is always 1, but for 1 plus 1, carry is 1. As you know, 1 plus 1 equals to 2, carry is 1, and only for the 1 plus 1 plus 1, 3, the sum equals to 1 and carry is also 1. 1 plus 1 equals to 3, and binary 3 representation is 1 1. So that's how we can observe the function of a full adder circuit in multisim platform. Next circuit that I want to share with you is the decoder circuit and multiplexer circuit. We know the use of decoder and multiplexer, that to decode any code, we generally prefer decoder circuit, and especially from binary coding to whether what is the value of binary 0, 1, 2, 3, we use decoder. So here is the example of 2 to 4 decoder. Two input you can observe in the form of A0, A1, and there are 4 outputs. In this particular circuit, what thing is missing? Enable input terminal is missing here. It is not drawn in this particular diagram. But if you use, or any of us, when we are using IC, decoder IC, we have enable input terminal as well with the IC. So when we'll try to implement this one, we'll go with the enable input as well. Let's start designing or drawing that particular circuit. It is just partially I have started, so I have to complete. It will take some time. So that's why at the beginning I suggest you, those who are using online platform, they can also parallelly do it. So here 3 input AND gates are taken for the decoder. One will act as a enable input terminal. This particular terminal we can use as a enable input. That's why one extra input AND gate is considered here. So other input terminal for the time being not required, and rest of the connection we have to do in similar fashion. This one should go to here, this one with this terminal. Similarly, the third AND gate connection should go here, and the other terminal should connect at this input, and the fourth one direct input, fourth one connect as direct input, just like AB only, you can say. I name the input as AB, A0, A1 there, so I'm changing the names. So A0, A1 input connections, first one comes from A0 bar and A1 bar. Second one comes from A0 but A1 bar. For third one, it comes from A0 bar and A1 directly, and fourth one A0 and A1 direct connection. And to observe the output, we have to connect the LEDs. We need 4 LED for 4 output. And a ground terminal for all. Let's connect all the output terminal of the AND gates with the input terminal of LEDs. And to complete the circuit, connect the output terminal of LEDs with the ground. So here we have completed the circuit, and this one will act as a enable terminal now. As I have connected enable input directly, so you can consider that it is active high enable. That is, if the enable terminal is high only, then only circuit will work. But if the enable terminal is 0, circuit will not work. That means whatever be the input, it will not be functioning. And we know that, as we know that the decoder circuit, based on the given input A0, A1 value, particular terminal is on. So as I have made enable terminal is 0, thus if we change the input here, there will be no difference in the output. It will work only when I turn on the enable input as high. So that's why it is known as active high enable terminal. So for 00, first LED, we generally name it as D0 though, is high. For this one is 1, 10 indicates binary 1. So second LED is high, and for 10 it is binary 2. That's why third LED is getting high, and for 11 the final one represent the 3, binary 3. So that's how decoder circuit functions. Now the next circuit is multiplexer. To implement the multiplexer, we can modify the decoder circuit directly, because multiplexer circuit is similar to just some modification we have to do, that we have to jot down all the outputs and get outputs in a single OR gate. So I connect here 4 input OR gate, and this time I don't need so many output. We need multiplexer. We know the multiplexer's function. It combines the different input in a single one. That's why we need a single input only, but we need multiple input terminals. We are going for 4:1 multiplexer. We are looking for implementing 4:1 multiplexer. That's why let's place 4 input terminal here. And this time I am using the enable input of previous circuit as a input for multiplexer. That's why all that lines previous connection deleted. So first one, let's name it as D0. D stands for data 0. Similarly, data 1, third one, data 2, and the fourth one as D3. So first data is connected with the first AND gate, second data input connected with the second AND gate, third one with the third AND gate. Now if we want to connect enable terminal with this circuit as well, then we have to go for 4 input AND gate. Just to save our time, let us go with the same circuit. Participant latter can implement the same circuit with the enable input terminal as well. As the decoding part of this multiplexer circuit also same, so that's why we have used the previous circuit. In case of hardware laboratory also, we go by the same process. We initially take the 3 input AND gate. One of the terminal is grounded over there, because in IC enable terminal is available in the form of active low. So now my 4:1 multiplexer or 4:1 multiplexer is completed. If we go for simulation, we know here, once again, just rename this select line terminal. Let's name it as S0 and S1. Select line as S0 and S1. It will be easy to understand. We know for multiplexer we have 2 input section. One is called select input section. One is called data input section. Output depends on the select line, and with the variation of input terminal, output changes. Here, firstly, we have selected S0 and S1 equals to 0, 0. That means D0 line will be selected. So for 0, output is 0, and for 1, output will be high. That is, whatever input we are giving at this terminal, similar output we are observing at the output of multiplexer. 0 for 0. If you change the other input terminal, it will not create any effect on the output because these lines are not selected. Similarly, if we go for the 1, 1 selection, now this output will start depending on the last one. If 1, output high, if 0, output low. So similarly, if we vary these inputs accordingly, the circuit will be functioning. So that's about the multiplexer circuit. So let's do some sequential circuit part. We have we know that digital circuit we can divide into two categories, that is the combinational part and the sequential part. In combinational part there are many modes like subtractor, comparator, encoder, etc., etc. So participants are advised to go for other circuits when you will be performing online simulation. In case of sequential circuit design, we know that the basic component of sequential circuit design is flip-flop, and flip-flop itself is designed by using the universal gate, NAND and NOT. So in this platform, direct flip-flop is not available. So we can implement different flip-flop SR, JK, T, D by using basic gates and universal gates. But the counter circuit, for counter circuit direct or register circuit directly flip-flops are not available. So I will show you here how to do that experiment. That is the implementation of SR JK flip-flop. So this circuit is very popular circuit for the SR flip-flop, and if we modify the SR flip-flop, that means connecting two input terminals through a D gate, it will become a D flip-flop. Then to overcome the problem of D flip-flop, that is the one stage of the input, we go for the JK flip-flop. JK flip-flop don't have the one input, undefined input problem, though there is some race around condition problem present. And if we modify the JK flip-flop by connecting the two terminals, then we can have T flip-flop or toggle flip-flop like this. So I show you one or two circuit based on in sequential category. In sequential circuit design part, first of all, we must observe the function of latch. If we can understand and do it successfully, then other circuit implementation will not be difficult. That's why let us first implement the SR latch, which will help us to implement the other circuit easily. For SR latch, we require either 2 NOR gates or 2 NAND gates. I am drawing the circuit using NOR gates, and now I need the output section, 2 outputs. And now is the feedback circuit. Output of the first gate goes to the input of the first gate goes to the second NOR gate output, and second NOR gate output goes to the first output, right? So here is the circuit completed. This one is the S terminal, so just diagonally this first LED will act as a Q and second LED will act as a Q bar. So just let us name it. So you cannot use any symbol over here, that's why P has written directly. So for S equals to 1, R equals to 0, Q goes high, and for 0, 0, it holds the previous state. That is, Q remains 1 and Q bar remains 0. Now if I change R to 1, then Q reset to 0 and Q bar set to 1. And similarly after that, if we make both the input 0, it will hold on the state. That's why 0, 0 input for the NOR gate is known as hold on state. But we know the problem of SR, that 1, 1 input cannot be applied directly as both the output become same. That's why it is called undefined states. We must not use the 1, 1 input to the SR. So once we have gone through the SR latch, we can modify this circuit directly to implement SR flip-flop by connecting one additional synchronous with the circuit. So for that we need AND gates, additional AND gates are placed here. And we need one synchronous input in the form of clock. So here directly clock, the same input also be used as a clock terminal as well. So we can name it as CLK, clock input terminal, to use this particular terminal as a clock. So same circuit, SR latch is modified to SR flip-flop, and again if we simulate this, we will observe the similar behavior with additional feature as clock equals to, as clock is present there. So if I now make S equals to 1, and after the clock is applied, it will change at the output. Okay, if we make the clock 0, there will be no effect. We may change the input, we may switch the input, there will be no change at the output terminal until and unless we change the clock over here. As I switch the clock, so switch the input R to 1 and S to 0, and now we apply the clock here, it will change, right? It will change the output similar to the SR latch. And memory behavior, that is hold on state, is same. If we make the R and S 0, it will hold on the previous state. Though we apply the clock pulse, no problem. It will hold on the previous state, right? For 1 0 state, Q goes 1, and now you can observe the memory state similar to the previous one. So here is the implementation of SR flip-flop by using NAND, by using NOR gate. If you replace this NOR gate by using NAND, and similarly this AND gate by using NAND, the same circuit, that circuit also behave like a SR flip-flop. Now, if we want to convert the same circuit to D flip-flop, we know there is a simple connection, that is in D flip-flop we have only one input terminal. These two terminals are sorted together using a NOT gate. So one NOT gate, let us place here. Now this terminal you can rename as D for D flip-flop. In case of D flip-flop, if the input is 0, output will be 0, and if the input is 1, output will be 1. So if 1 is applied and clock terminal is high, then Q becomes 1. And similarly, if we made D equals to 0, then with the change in clock, the Q will be 0. This particular flip-flop, D flip-flop, or also known as the data flip-flop, is very much used as a memory element, because once you apply 1 here, the 1 will be latched, and if you are not enabling the circuit by using the clock terminal, that 1 will remain present in the circuit. Maybe your data is removed from the input terminal. If the clock is not triggered or enabled, that the same data will remain present or latched into a device. That's why it is particularly used for the data to act as a memory element. So here is the implementation of D flip-flop by using NOR gates. Similar thing can be done by using NAND gate also. And now the last one, that is the JK flip-flop. JK flip-flop circuit, as you know that one additional feedback is given from the output to the input terminal to overcome the problem of one input state, that is the forbidden state in case of SR flip-flop or undefined state. One additional feedback is given here, and the inputs are renamed as J and K. Output here Q bar Q. The internal circuit is almost same as additional feedback is given. That's why 3 input AND gates are used here. Other things are almost same. So if we simulate this circuit, initially J equals to, if I make K equals to 1, then Q bar will be high for applying the clock pulse. Okay, if we apply the clock pulse, Q bar will be high for K equals to 1, J equals to 0, and for 0, 0, it is the hold on state, similar to SR flip-flop. It is hold on state. May there be, we are changing the clock 1 or 0, doesn't matter. Once J and K equals to 0, 0, it hold on the state. Similarly, if I make the input J terminal high and applying the clock here, Q bar 0 and Q becomes 1, and similar to that, that is the memory condition. For J equals to 0, K equals to 0, it is memory condition no matter whether we are applying the clock or not. It is hold on state. Now the problem for 1 input terminal in simulator also we cannot observe it properly, because as we have gone through the theory part, for applying the 1 input, a race around condition occurs, that is output continuously toggle from 1 to 0 and 0 to 1. That's why it is very difficult to predict the output. To overcome this problem, we should go for the master slave flip-flop or JK flip-flop. The same thing will be observed in simulation also. Once you make the clock high, you can change, you can observe the ambiguity at the output. That is due to the race around condition. It can be solved by using master slave flip-flop, that means 2-stage JK flip-flop. And if we perform this experiment in hardware lab also, this kind of ambiguity or problem, race around condition, is very much visible. So now the last one, I'm not going into it, that is the just shorting the 2 terminal J and K. We can have the T flip-flop as well, that is the toggling flip-flop. So with this, I conclude my session and suggest all the participants, you can implement different kinds of circuit by using multi-sim, and not only for the digital but also for circuit theory you can use different components, and for analog laboratory also you can design different transistor, diode and other component based experiment. Thank you all.
তুমি মিউট করা যেত। Thank you, sir, for wonderful session. I hope that students will get benefited by using multisim through this online platform. So just the days before, that is on Tuesday, I have shown about the using multisim by installing multisim in the PC. Today, as you have shown, that the multisim using the online platform, that is online multisim. So one question is that, sir, is there any limitations of this online platform? That is the number of components that we can take.
No, so far I haven't observed yet the
Okay.
number of component I require to use for the laboratory experiment. We have not observed any problem. But sometimes I face the difficulty that components are not appearing directly or properly. And for that, this kind of problem student may also face. For that, I suggest you just close the window and reopen it, and
Okay.
it will be better.
Okay. Okay. Another question is that, sir, I have also not tested. Have you tested a multism in Android phone?
Android phone, when I perform the same experiment with my students, they have done in Android phone. They open this window as their directly software is not available, app is not
Okay. Okay.
available.
Okay.
They open
Okay.
the
Okay.
browser and do it.
Okay. Okay. So using browser, so students, you can use your browser and open this multism in online mode. So Android app we have not tested. Maybe there are some Android app, but we have not tested.
We haven't seen it yet, but
Okay. Okay. Okay.
opening browser they can do it.
Yeah, yes. So thank you for your wonderful speech for this uh, students workshop on virtual lab and techniques. And we hope that the students will get benefited and they will perform the experiments related to their labs and they submit the report accordingly. Thank you once again from on behalf of EC department with heartiest thanks to you.
Thank you
So
very much, sir.
here we end up the students session. Thank you, sir.
Thank you very much.
ব্যাস এড করে দে সুন্দর স্যার ভালোই করেছে আজকে একদম